Hello everyone, welcome back to the fourth lecture of the lecture series of operating system. Today we discuss about the system structure once again. Myself Moushmi Shaha, Assistant Professor of Computer Science and Engineering Department from Narula Institute of Technology. So first we begin with interrupt. What is interrupt? An interrupt is a signal to the processor to suspend the current execution program and run a specified routine. So CPU can know the state of a device through polling the device and interrupt by the device. Whenever the execution of a routine is completed, the processor switches to the original program. Basically, interrupts are four types. These are the program interrupt, timer interrupt, IO interrupt, and hardware interrupt. So what is program interrupt? This type of interrupt generated by illegal instruction in the program, such as division by zero or arithmetic overflow and reference outside a user allowed a memory space. So whenever this type of program interrupt happen, the operating system send a signal to the processor to suspend the current executing job. Okay, and the next one is timer interrupt. So this type of interrupt are generated by the clock within the processor. So whenever the time slot of the processor expire, the operating system send the interrupt signal to the processor to suspend the current job. And the third one is IO interrupt. This type of interrupt are generated by input output controller. For example, if a CPU read command to IO module, so the IO module is ready at the time, then the IO module send the interrupt signal to the CPU about the status. And the fourth and last one is the hardware interrupt. This type of interrupt are generated by hardware component. Suppose if any hardware component fail due to the technical problem, they generate an interrupt. For example, memory failure or power failure to a particular hardware device. And interrupt structure. In a personal computer system, the interrupt are happen to desk, keyboard, printer. These are the IO devices. This device generate the IO interrupt. Whenever the IO device has finished the given work, it causes an interrupt. The interrupt signal then detected by the interrupt controller. Okay, so whenever a IO devices generate a interrupt, then the IO controller detect this interrupt. If no other interrupt are pending, the interrupt controller process the interrupt immediately. If there is no interrupt, okay, then the controller processes the interrupt immediately. If another one is in the process, then the interrupt suspend temporarily. Okay. So interrupt can be maskable and non-maskable. Maskable interrupt can be masked or ignored or deferred for processing. Non-maskable interrupt causes either an error. The pending interrupt can be daisy-chained or kept in a priority interrupt queue. So a separate segment of code determine what the action should be taken for each type of interrupt. And interrupt transfer control to the interrupt service routine, generally through the interrupt vector, which contain all the addresses. So now we discuss about IO structure. After input output start, the control return to the user program. Okay, only when the IO completion. It wait instruction idle CPU until the next interrupt. After the IO starts, the control return to the user program without waiting for an IO completion. So like system call. It is a request to the operating system to allow the user to wait for a I/O completion. Device. The status table content entry of each I/O device indicating the type. Then the operating system index into the device table to determine the device status and to modify the table entry including the interrupt. Now the operating system structure. Mainly operating system have simple structure, layer structure, virtual machines, design goal and implementation issues. So what is simple structure? In monolithic system, it is possible to have a list of little structure. So it is called simple structure. The service is like system call provided by the operating system that are requesting by putting the parameter into well-defined place, such as in register on the stack, or there is executing by a special trap instruction as kernel call or supervisor call. The Unix is an example of such a system that was initially limited by hardware and functionally then grew up beyond their original scope. It consists of two separable parts, the kernel and the system program. The kernel is the further separated into series of interfaces and devices which are added to the expand over the Unix evolved. We can view the traditional Unix operating system are being layered as in the second picture. Okay. So there are the different structure that have been followed by the beginning till now. So first of all, we discuss about the simple structure. So look at the picture. The simple structure is a structure that has followed by most of the operating system and that was designed by very beginning, and this simple structure of operating system did not have a well-defined structure because it was this operating system those were defined very beginning. So the diagram we see here, the figure is the simple structure. Here the Microsoft disk operating system or MS-DOS is like it follows simple structure. So we know the MS-DOS an old operating system which was designed very long back. So at the bottommost we see the ROM BIOS, the device driver. Think of this as the base hardware, then the top of this we have device driver, then we have resident system program, and then we have application program. So here we see this is look like a layer structure, but the MS-DOS device driver connected to the ROM device and the resident system program also connected to the ROM BIOS through MS-DOS, or it can directly interact with the device driver. The application program also connect through the resident system program, or it can directly. So it is look like a layer structure, but actually it is not. The second one is layered approach. The operating system divided into number of layers, each built on top of the layer. The bottom layer is known as level 0. It is the hardware, and the highest is the user interface. So the innermost layer is known as hardware and the outermost layer is the user interface. With modularity, the layer is selected such a way the use function of operation service only the lower level. So this level 0, this is the hardware, then operating system, application software, okay, then user interface. This is another layer structure. And what is microkernel system? The microkernel system structure move as much as kernel into user space. It communicate takes place between user module and using message passing. Okay, it communication through message passing. The benefits are it is easier to extend the microkernel and it is easier to port the operating system to a new architecture. This is more reliable and more secure. And virtual machines. If virtual machines take a layered approach to its logical conclusion, it treats hardware to the operating system kernel as though they were all hardware. A virtual machine provides an interface identical to the underlying bare hardware. Here, the operating system creates an illusion of multiple processes, each executing one of its own processor with its own virtual memory. The example is virtual machine monitor. The resources of the physical computer are shared to create a virtual machine. The CPU scheduling can create the appearance that the user have their own processor. The simultaneous peripheral operation online and the file system can provide the virtual card reader and virtual line printer. A normal user time sharing terminal services virtual machine operators console. So the advantage and disadvantage of virtual machines are the virtual machine concept provide complete protection of the system resources. Since each virtual machine is isolated from other virtual machine, this isolation, however, permit no direct sharing of the resources. Okay, so no direct sharing is happened in virtual machine. The virtual machine system is perfect vehicle for operating system research and development. The system development is done on the virtual machine instead of physical machine. So it does not disrupt normal system operation. And also the virtual machine concept is difficult to implement due to the effort required to provide an exact duplicate to the underlying machine. And the system design goals are from the user perspective, user goal is the operating should be convenient to use, it is easy to learn, it is more reliable, fast and safe. And from system perspective, the system goals are operating system should be easy to design, it is easy to implement and maintain, as well as it is flexible, it is reliable, if it is error free, and it have to be efficient. Now we discuss about direct memory access structure. In direct memory access structure, we used high-speed input-output device which is able to transmit information at a close to memory speed. The device controller transfer block of data from buffer storage to directly into the main memory without the intervention of a CPU. And only one interrupt is generated per block rather than one interrupt per byte. And then we discuss about hardware protection. There are mainly 4 types of protection is there. One is dual mode operation, second one is IO protection, memory protection, CPU protection. So in dual mode operation, what happened? Sharing system resources require operating system to ensure that an incorrect program cannot cause other program to execute incorrectly, and to provide hardware support to the differentiate between at least 2 mode of operations. One is user mode, that is executing done on behalf of a user, and second one is monitor mode, where execution done on behalf of operating system. Now, in dual mode operation, what happened? Mode bit added to the computer hardware to indicate the current mode. Like for monitor, it will be indicating by 0, and for user, it is indicating by 1. When an interrupt or fault occur, the hardware switches to monitor mode. Okay, the diagram is shown in the picture. Now the privilege instruction can be issued only in monitor mode. And IO protection. All input-output instructions are privileged instruction. The input-output devices are inherently protected by their respective device electronics. And how memory protection is happen? It must provide memory protection at least for the interrupt vector and the interrupt service routine. In order to have memory protection, we have to add some additional architectural support like register that determine the range of a legal address of a program. Like we have to provide a base register and a limit register. The base register holds the smallest legal physical memory address, and the limit register contains the size of the range. The memory outside is defined, the range is protected. Here in this diagram, here the monitor, the job 1 base register is 2560, and with the limit register size it closes. For job 2, the base register is 300040 and its size is 120900, that is its limit register, and base register plus limit register, it finishes here. Okay. So here the hardware address protection is happen. A CPU generate an address with the help of base address and limit address and store this address into memory. The hardware address protection. When the execution in monitor mode, the operating system has unrestricted access to the both monitor and user memory. That time, the load instruction for the base and limit register are privilege instructions. Now CPU protection. We use timer and interrupt computer after specified period to ensure the operating system maintain control. The timer is decremented every clock tick. When the timer reaches to the value 0, an interrupt occurs. The timer commonly used to implement time sharing. The timer is also used to compute the current time. And load timer is a privilege instruction. Now we discuss about the common component of the system. The process management, memory management, file management, IO management, secondary management, protection system, command interrupt system. These are the common system components. So processor management. What happened in processor management? A process is a program in execution. A process need the certain resources include CPU time or memory or file or IO devices to accomplish its task. The operating system is responsible for the following activity. That means for process creation or deletion, for process suspension or resumption, provision of mechanism for process synchronization and communication. All are happen during process management. In main memory management, what happened? The memory is a large array of word or bytes. So each with its own address. It has the repository of quickly accessible data shared by the CPU and IO device. The main memory is a volatile storage device. It loses all its content when the system failure. The operating system is responsible for the following activities in the connection with the memory management. That means the operating system keep track of which part of the memory are currently being used by the and by whom. The memory management decide which processes to load when memory space become available, and allocate and deallocate of memory space when it needed. And in file management system, a file is collection of related information defined by its creator. Commonly, file represent the program, both source file and object file. The operating system is responsible for the following activities. These are file creation, file deletion, So creating a directory and deleting a directory also support primitive for manipulating files and directory, mapping files onto secondary storage, file backup and stable storage media, and IO system management. The IO system consists of a buffer cache system, a general device driver interface, the driver for specified hardware device, simultaneous peripheral operation online or virtual device. And last one is secondary storage management. Most modern computer system uses disk in the as a principal online secondary storage medium for both program and data. Because its size is large, it is low cost. Access time is between DRAM and tapes 1 millisecond. Okay. The operating system is responsible for the following activities. These are free space management, storage allocation, disk scheduling. And in protection system, what happened? The protection referred to a mechanism for controlling and access by the program, processes, or user to boot the system and user resources. The protection mechanism must have distinguished between authorized and unauthorized uses. It specifies the control to be imposed and provide a means of enforcement. Command interpreter system. Many commands are given to the operating system by the control statement, which deal with process creation and management, IO handling, secondary storage management, memory management, file management. This is known as system call. The command consists of job control, like there are some commands like mkdir. This command is used to create a directory, rm to remove something, ca to change mode or permission of a file or directory. We use chmod command. To copy, we use cp command. Del to delete something, directory command, copy. These are some commands. The program that read and interrupt the control statement are called variously command line interpreter and cell. Its function to get and execute the next command statement. And the operating system provides the following services, that is program execution, IO operation, file system manipulation, communication, and error detection. The system is capability to load a program into memory and run it. It's the objective of program execution. The IO operations, since the user program cannot execute IO operations directly, the operating system must provide some means to perform input-output. In file system manipulation, program capability to read, write, create, delete, or update of programs or files. In communication, exchange of information between processor and executing either on the same computer or on the different system tied together by a network. For this, we use shared memory or message passing. Error detection. It ensures the computing by detecting error in the CPU and main hardware, in IO devices, or in user program. The additional operating system functions are: the additional function exists not for helping the user but rather to ensure the efficient system operations. Like the operating system's main job is resource allocation. It allocates resource to the multiple user or multiple jobs running at the same time. It keeps a track of the record of which user use how much and what kind of computer resources, for account billing, for accumulating user statistics. Protection. It ensures all the access to the system resource and controlled. Thank you for listening. If you have any query, feel free to ask me. Thank you all.